Okay. Hi, this is Nalini Elkins with Industry Network Technology Council. Welcome to the webinar on DHCPv6. If somebody can send me a quick note to let me know you're hearing me okay, that's perfect. Okay. I do hear people sending me, that's fine. Thank you so much. Okay, so welcome to the webinar on DHCPv6. We are recording the session, and we will also be making the foils, the PowerPoint, available afterward. Do let me know if there's any problems during the session hearing me. We will go ahead. If you have questions, go ahead and type them into the chat window, and some of the other folks might go ahead and try and answer those. Otherwise, I will get to them afterwards. And we do have a guest speaker at the very end. I just see him coming on. We have Michael Richardson, who is one of the co-authors of the DHCPv6 RFC. So thanks so much, Michael. And Michael will stay on at the end and take some questions, which will be great. So save your questions for him too. Okay, so let's go ahead and get started. So as you know, this for most of you have been on here for most of these webinars. You guys are gluttons for punishment. I'm just going to tell you that. So we have funding from the ISIF Asia, the APNIC Foundation, and we have had funding, of course, from Aaron in the past, and we have funding for a current project with Aaron. This is a joint effort with the India Internet Engineering Society and Industry Network Technology Council, both of whom are nonprofits, and both organizations would love to have you guys as members. Do write to us or go over to our websites and join us as members. As I say, we're nonprofits. So, of course, our project, it's a multi-year project aimed at enterprises to really get into IPv6 deployment. We have a project coming up soon, and you guys will be here getting a survey pretty soon here for how security and applications, two of the really big pain points that we feel that you're going to have. And do help us with filling out that survey, because that will help us to figure out where to go next, what kind of best practices, papers we need, where you are. I'll give you a quick preview. We're taking into consideration things that most enterprises have, such as disaster recovery, change control, and operational impact of IPv6. These may have been overlooked in some of the previous attempts. So that's just a teaser. So please do help us to help you. So we have done quite a few webinars so far. We are now into the second column here. We're doing DHCPv6, and we will have one of our folks from IIESoc, Mohit Taliani. He will be presenting the DHCPv6 lab next week, so stay tuned for that. A few words, like seriously few, about me. I think you guys have all seen this quite a bit before. I develop products, and I also am one of the founders of the Industry Network Technology Council, which is a nonprofit aimed again at enterprises. So, okay, so what are we going to talk about today? So this is the agenda. You know, the reason we're talking about DHCPv6 is because you're going to need it. You're going to need to understand it. I would have a hard time thinking of any enterprise which is not going to use DHCPv6. And so the more you know, the better off you will be. And so, as I said, that's what we're going to talk about. What is the problem DHCP and, of course, DHCPv6 wishes to solve is how do I get an address? And of course, now we know that we can have not just one address per interface, but potentially multiple addresses per interface. And so how are we going to manage all the things that are in our toolbox? Well, we want to make sure that we have not just been given enough rope to hang ourselves with. I see people being quite creative, which I encourage, of course, but be careful. So we'll talk about, you know, that fine line between being creative and shooting yourself in the foot. So DHCP, just like DHCPv6, is called stateful. That means that you have a server and that you're keeping state at some point, and which is interesting. And so you're going to provide a device, or rather an interface. You're going to provide an interface with an address. That is what DHCPv6 is going to do. And of course, there's a number of complexities with DHCPv6, just as there was with DHCP, which is that there are many options that you can have with DHCP. In fact, that's the kind of thing that really you know, adds to the complexity, is what options am I using and how am I going to do them. And whenever you see something like this in the abstract, when you see an extensible mechanism, then you're thinking, extensible how exactly? Is it extendable through options? Is it extensible through, you know, extension headers? How extensible? And so with a DHCPv6, of course, you've got options. And do feel free to ask Michael Richardson questions about maybe the history of DHCPv6 and why things were done the way they were done. Sure, he would love to get those. So why an entirely different architecture? Excuse me. Why an entirely different architecture for DHCPv6? Why not just add it to DHCP? Well, you know, it's as I say, sufficiently different, and there's sufficiently different options for everything that you want to try to have them differently. And you know, it used to be even that people would have an entirely separate server for DHCP versus, DHCPv4, versus DHCPv6. But nowadays, what I see is combined servers. And so it could be one database, it could be multiple databases. And we might see too integration with DHCPv6 and things like IPAM. Down the road here, we will do, it's going to be well into the latter part of this year, the third quarter, fourth quarter, or early part of 2022, we'll look into IPAM and some of those things. Because as I say, that's something that folks do quite a bit of also. So let's review a little bit. We have talked about Slack way back in the beginning. It was quite a few presentations ago. And so what Slack is going to do is going to give you an address without needing a server. It will need a router, but it won't need a server, such as what DHCP needs. And so we'll see that, and Mohit will go ahead and he'll go ahead and review a little bit of Slack as well in his presentation in the lab. And so the other thing that's related is, of course, DNS, and in particular, dynamic updates to DNS. And so we'll talk about some of that as we go forth. So let's talk about basic functioning and kind of what we're looking at DHCPv6 defining. So you've got a few things to start with, okay? So you've got clients, somebody who's going to need an address. You've got servers, somebody who's going to grant addresses, and maybe some other things. And then potentially relays, who are going to be talking to more than one thing. So let's talk about clients. So that's going to be your endpoint. And so of course, when we say endpoint, what we really mean is that interface. We're going to have one or more interfaces who want one or more addresses, or they just want configuration. They may say, you know what, I got me an address, but I'd like to know something else, like what DNS server are we using on our network, something like that. I want to know something else. So DHCPv6 is very, very powerful. It can do more than just grant you an address, of course, as you guys know. So the server, the DHCPv6 server, and so he's going to give you your address and other information, whatever you ask for in these options, he's going to give you that. But you may have relays. You may say, look, I'm going to be connected to more than one network, and I want to have a centralized DHCPv6 server. So when you're laying out your topology of servers and clients, you will likely have relays involved, you know, in amongst all this this chaos that you're doing. So why are you going to need relays? Well, you don't want to have like a zillion, that would be the technical term, DHCPv6 servers. So you just want to say, look, I'm going to just have a bunch of relays and then consolidate all my action with a few servers, and then have them grant that, because you don't want to be making changes everywhere too. I think that makes a fair amount of sense. But you know, this is one of those things, it's like easy for me to explain, right? You know, as one of my partners says, rolls right off your tongue. Yep, rolls right off your tongue. You can have relays, you can have multiple relays, but you guys have the hard part, which is, okay, what do I have? How many DHCPv6 servers do I have? How many relays do I have? How do I organize them? That's really a lot of the problems that you're going to face, is doing all that work in your topology. How are you going to do that? So, okay. So, what are modes? DHCPv6 modes. Well, so as we said, we can provide either the host or both the host address and other addresses. Maybe you want to know what FTP server do we use. And again, as we talked about, when we do it using DHCPv6, it's stateful auto configuration. You can get state DNS information via Slack as well. This is relatively new. It was not that way in the beginning. And so, and we talked about that briefly before. That's RDNSS. One of the things, of course, when you're looking at the RFC number and you're seeing something like 7 or 8, then you can think, that's probably one of the newer ones, because that's one of the newer things that was granted. So that's another clue as to the newness. Now, DHCPv6 can also be used for renumbering the network. Now, I have my own opinions about renumbering the network, and if that's something anybody would actually in reality want to do on a large enterprise network, but I'll just leave that opinion for later. And we can go through. Let me know if you guys have some interest in that whole topic, and then we can see. We can do a little lab. We can say, okay, this is how renumbering works, and is that something that you want to use? Maybe you want to do it for something like a controlled VLAN environment, something like that. In any case, as I say, if that's of interest, please send me a note, and we'll see about covering it. Okay, so let's talk about exactly what happens. What happens for getting your address? What's this big old address we've been talking about? So first off, you're going to get your link local. You're going to get your link local for your interface via Slack. Your operating system is going to help you with that. And so let's say, yes, we did that perfectly. We have our Slack address. And then you can say, well, we're going to get our global unicast. Now, to review, what was our global unicast? That's the address that's going to allow you to, say, talk over the internet or talk on the other side of your router. Because if you didn't need to do that, well, you could just do everything off of link local, and maybe even some of your multicast groups. But it's unlikely that you want to be limited to just your LAN and your VLAN or your neighbors. You probably want to go out to the internet. And so how's that going to happen? Well, you're going to talk to your router, and he's going to send you a router advertisement. And the router advertisement is going to say in there, listen, people, on our network, how we do things is that we use DHCPv6 to get our global unicast addresses. And so then you can say, okie dokie, so now I know how we're doing things in what are the rules now for us. And then, of course, you'll join whatever the appropriate multicast groups are as well. That's another whole thing. I'm going to do a whole presentation on multicast groups. I threatened to do that one of these days, and the whole thing of how you join them, what it all means, and there is a great deal to be talked about in that whole arena. So one of the things, of course, that's going to happen with your Slack is you want to make sure that you generate a link local address that is unique. Because if you have the same link local address as somebody else, of course, you're liable to get confused. And now, when these were all based off of MAC addresses, everybody was like, well, sure, that's, unlikely to change. Having said that, and do ask Michael about this too. Michael, I hope you're happy with all the questions I'm throwing your way. There is quite a bit of effort being done to randomize MAC addresses. You may be interested in the Madness effort at the IETF, and quite a few OSs, I believe, already have randomized MAC addresses, and of course, randomization depends on the strength of the algorithm, and you can have what they call collisions. that's what used to, as I said, I don't want to get too far astray with doing hashes and so forth. But in that whole world, when you have multiple things you have hash collisions, basically that means that you have two hashes that have come out to be the very same number. And so it is possible that we could be running into something like duplicate address detection with linked local addresses now. Again, I suspect it's going to be very, very rare, but it's at least more convincible, more a potential for that is happening. And again, where you're going to see all that neighbor solicitation, neighbor advertisement, that kind of stuff. Again, we've talked about that a fair amount. So now, though, when we want to get our global unicast, well, that's a more interesting packet, right? That's your router solicitation, as I asked about. The router is going to say, what should we do? And of course, then, easy for me to say, router is going to say what we're going to do. But then remember, it's in your topology, your configuration. The router needs to be told what he's supposed to do. That's one of the things you're going to configure. And again, now I get back to configuring your topology. Is there may be some things that you want to say we're going to use DHCPv6 for, but if I have something, for example, if I've got, I don't know, a bunch of medical devices, which are small and they're IoT devices, well, you know what, I may just segregate all of those onto something and let them do Slack. And so it's, as I say, it is a very interesting and important question, is what are you going to use when? What is the most appropriate tool to use to serve what function? Because you may not wish to use DHCPv6 for things like IoT devices. So it's something to consider is the actual use, which is something that only you know is what we're going to do, what you're going to do on your network. This is just the tool that you have. So what are you going to get once you have the global unicast assigned? You're going to get the global unicast address, and of course, you're going to get your device identifier. And we'll show some of that happening as well. And so what is the advantage of DHCPv6? Well, the advantage is you can control it. You can control the address that you have. And where might that come in extremely handy? Well, it may come in extremely handy when you have servers. You may not wish to have servers have addresses that change all the time, or even addresses that are based on Slack, based on some random number or some MAC address that may or may not change. You may want to say, this is my FTP server, and I'm going to give him the address : 1, something like that. And I know that's my static address. It's not going to change. Now, that's, again, an entirely different question, is how do you actually want to do static addressing? And that's what kind of scheme do you want to use? And we talked about that a bit when we did the whole address planning presentation. Do go up to those presentations. They're on our website, and if you want to review some of the potential pitfalls to what can happen when you have static addressing. Yes, I'm getting a question which I'll answer just real quick here. Most questions I'll answer answer later, is we can control addressing with DHCP for IPv4 as well, right? Well, of course, but this is for V6. DHCPv4 is not going to give you V6 addresses. You're going to need DHCPv6. That's why you have it. That's why you have it. So let's do a summary of our address allocation. So when a new client initializes, you're going to get your link local as a part of stateless auto configuration. You're not going to be able to go very far with that. You're not going to go very far. You're going to go stay on your own link or VLAN or whatever. Next thing, the node is going to send a router solicitation, or if it actually sees a router advertisement appear, that will let it know that it should use stateless or stateful. And that's in the router advertisement. And there's a whole different question about exactly when are these router advertisements sent, what is the frequency of that, and Mohit he'll show you one of the configuration parameters you can use. The only reason I say that is I know we had a problem, and maybe one of the other speakers can speak to this. In one of our labs, we had a problem where we were not getting that router advertisement, but every 5 minutes or something. And so we're like, wait a minute, we don't be waiting that long. So do pay attention to that parameter. So once you've got that router advertisement that says, I want to, we're going to use DHCPv6 on our network. So what are you going to do then? So you're going to say, well, but what DHCPv6 server? How do I know? I mean, do you actually want to hard code the DHCPv6 global unicast or link local address somewhere? Probably not. Probably not. And so that's when we use multicast addresses. So there's two well-known multicast addresses that you can use. You can say, okay, so all DHCP relay agents and servers. And so let's break this multicast address down a bit. So if we're seeing FFO2, what's the scope? What's the scope? So what you're seeing is anybody on my link. If there's anybody on my local link that I can talk to, link local, that I can talk to who says I'm a DHCP relay or server, then please talk to me. Let me know what we should do. If there's not, well then let me go to a different scope. Notice that it's going FFO5. Let me go to a wider scope. Let me say within our organization, is there anybody who says they're a DHCPv6 server? Yeah, you know what? I suppose you could look for a relay further too. I guess that's an option. But this is kind of traditionally what you do, is you look for these. So notice how multicast is used very, very frequently. And so you've got to be able to have these guys, when you bring up that DHCPv6 server or relay, you got to make sure that this guy has joined that multicast group so he can respond. And that's also real fun to see. Yeah. So, well, and how are we going to then talk to each other? Well, we're going to start using UDP. This is an interesting conversation too. I had a conversation with a young man who's a developer the other day, and he was talking about TCP versus UDP. And he's like, well, why would anybody use UDP? Well, you know, a lot of applications, if they're quite intelligent, for example, DHCPv6, if they're quite intelligent, such as DHCP, DNS, Quick, they're going to do a lot of their matching of transactions, even recovery, all that kind of stuff they're going to do. So you want something as lightweight as possible. And so the well-defined ports then is you're going to listen, if you're a client, on DHCPv6 messages on UDP port 546. So of course, as Michael talked about before, is that something you're going to want to look in your firewall with? Sure you are. Make sure that's open. And of course, then you're going to listen for messages. If you're the server or relay, you're going to listen on port 547. What addresses are we going to use? I've been throwing global unicast, link local, this, that, and the other thing at you. So clients are going to use link local addresses for sending and receiving DHCPv6 messages. Notice what you're talking to this DHCPv6 server. You're talking to him via your link local address, and the DHCPv6 server, he can be either this part of this multicast group or else on his link local address. And so they're gonna talk back at you using link local. So and why do we use multicast? And this is an interesting summary, and I stole it from a conversation that Michael and I had. Michael Richardson gave me a great analogy, which is, as I say, wonderful. So why do we use multicast? Well, first you want to use a list of eligible folks, whatever they are. If you want to date or you want to marry or whatever, that's the list of your eligible people, and those are your servers. And so everybody says, well, I'm available, and I'm available. And then the step two, if you really go to date one, well, you're not going to go to everybody for dinner. You just go with one at a time. Now that's mostly done Unicast. And so then what are the exchanges? What are the exchanges that you're going to see? Well, let's look at some simple exchanges. So this first simple thing can be, well, I'm going to do a solicit or a request to a client, and the server is going to come back with either an advertise or a reply. And so then the client says, okay, you've told me what I want to do. I'm going to process that and then maybe do something else based on that. So client to server, these are rather a full list of the commands, and in the appendix we've got more. And I've got some packets to show you in a bit. And Mohit will show you a great many more packets and show, excuse me, so the server running in the lab. So the basic commands for the from the server to the clients are the advertise and reply. You also have reconfigure. Again, that's in the appendix. So if you want to talk to the relay, what do you have? You have a relay forward and relay reply. Unfortunately, we don't have enough time to talk about relays at this point. Do send me a note, and then we can do later. We can do something with relays, both in the lab as well as a theory session on relays for that. So step one, what are you going to do? You do the solicit. And again, as I say, you send it to all DHCPv6 relay agents and servers multicast address. You're saying anybody out there. Then everybody responds back with an advertise. So you could get multiple people coming back to you, and they both say, yeah, I can do this, I can do this. And it's kind of interesting. I just got a message. There's a couple of messages that I'll take on real quick. Are DHCP snooping protections widely available? Interesting. Let's cover that later. And because there's a few things. That's a big topic, and we should probably cover that in its own arena. And then of course I have my own opinions. I am not lacking for opinions. As to what's available and what's not available, and what will be and what should be good, and what else needs to be done. But that, as I say, let's cover that later, because as I say, there's another message coming in saying that there were NICs sleeping and causing multicast storms and performance issues. Sure, to me, I tell you something. I think that's the kind of stuff that we can put up some products. I get a little nervous about putting up vendor products, but maybe some open source products, and see how they do in some of these kind of issues with that. But I think, to be honest with you, I think that's that whole area of security and performance and what's available, what's not available, it's a big issue. And I'll cover some of it in a coming up presentation, but we can take this whole area of multicast, DHCPv6, multicast storms, snooping, all of that. I'm going to defer that to something else. And again, if anybody would like to talk in the question and answer period, do let me know. But I'm going to push this off to a further session, and then we can talk about it. Yeah. So to keep going, is we choose one of the servers and then send a request message. So we're going to say, okay, so now we're going to start talking Unicast. Now we start talking Unicast, and then so we're going to send you a request, and then the server says, okay, well, now that you picked me, this is exactly what we do. Again, here's a little summary of that, and let's keep going. I'm going to go to the next area, because I want to get to some of the packets. So again, why might you have multiple packets or multiple server? Again, this is what you're going to do. You're going to decide, how much redundancy do I want to have? What happens if this guy goes down? Who is my primary? Who's my secondary? And then, of course, what have I granted? What have I not granted? Where's the database? These are all your fun challenges. And so you need to know, the client needs to know which is the primer and what's the backup, so he can go to it. You could also have somebody be overwhelmed. Why are we doing multiples? Is I'm just busy. One thing that I always like to do in this kind of situation is I'm a big believer in logging. Is if you had to go to the backup, then I'd like to know that, because I'd like to know, do I need to get some more space for this? Do I need to have, is this box just too small? And now I'm going to throw in something that again, I threatened to do from the security area and the operational area. I want to actually dig into a whole topology section next time, because some of this stuff happens, frankly, when you're going into a disaster recovery mode, or if you want to do like a hot backup. You're like, okay, for example, we just had a hurricane at our data center, and then in 30 seconds, I need to be up and running in another whole region, which is my hot backup site, which is in ideally a non-hurricane prone area. It may be prone to something else, but potentially not the same hurricane. So, but you see what I mean is it's, again, all well and good for me to say all that, but the whole, figuring out of your topology. And now you've got not just DHCPv4 to deal with, but DHCPv6 to deal with in doing all this. Yeah, but ideally, you can have one server who's running both protocols. So let's take a look at some packets. I'll answer one quick question. One quick question about the solicit. And so the solicit is sent as multicast, but the advertisement comes back as a unicast. Well, let's go look. Let's go look, because I'm going to show you those packets and we'll see what happens. So But one of the things that we're going to need in there when we start looking at packets is we're going to need what's called the identity association. In so many words, it's the address that you give. As I say, this is my way of summarizing this whole set of this whole big paragraph and everything else. Is that's what you're going to give. You're going to give at least one identity association for this, and you can have, of course, a static address, or rather a non-temporary address, or you can have a temporary or private address. Why might you have a private address? Is you might want that address to change. You might want it to change quite a bit for clients. You might not want it to change for servers. Yeah, and so that's something else. Okay. You may also want to have an identity association for prefix delegation. So basically, what's prefix delegation? You can have a pool of prefixes, and you can say, this is my prefix, and I'm going to take parts of it and give it to other people. You can also have a prefix hint. You can, what kind of hint? You can say, I want you to give me a prefix size of a /56, not a /64, and the server can ignore that or not ignore that. That's something that is at the discretion, but you'll see that. So let's go through some screenshots and some packets. You notice that before any V6 addresses are allocated, we've used Slack, stateless auto configuration, to give this LAN both a V6 link local address as well as two IPv6 global unicast addresses, and you can see here the link local of the gateway. Okay, so when we start initializing, here's the packet trace, and so what are we seeing in here? We're seeing the solicit, advertise, request, and reply. So let's go back. Just from this metadata, what do we know? So what's this address? Solicit is going over the link local, going to what? Going to this multicast address. All right, advertise is coming from his link local, going back to the other guy's link local. Then, so that was the question before. So now we have the request. Again, the request is coming from the client's link local, going to this multicast address for the servers that you want. I mean, this multicast address. Then the reply is going to come again from the link local address. And so it's kind of good. It's kind of good to just go through this and see if that makes sense to you as to when multicast is used and when link local or unicast address is used. So let's drill down a little bit. So first thing, what we're going to do, we're going over port UDP. We're going over UDP, source port 546, and the desk port 547. All righty, and what are we doing? We're doing a solicit. And here's our transaction ID. So remember I said DHCP is a pretty smart cookie. He's going to keep track of what he's sending. Because why? Because this client could be sending multiple requests or multiple solicit at the same time. So you're like, well, which one am I answering? I don't want to be answering the wrong one. Okay? And then so yeah. So he's going to, and that transaction ID is going to match the advertise that's going to be sent. And then what's that destination? The link local, I mean the destination multicast address. It's that FFO2::1:2, and that's all available DHCP servers on what scope? Anybody on my link. So anybody on my link who can give me a DHCPv6 address, well, you talk to me, please. So the next thing, what else is he doing? Well, he's got a bunch of option types here. Well, so the other thing he wants a DNS name. He's like, well, I don't just want an address. I want me a DNS server. And what I'm looking for is a non-private address. So that's a couple of things. All right. So then, okay. So then what do we get? This guy gets this address because he has joined that multicast group. And he says, yep, that would be for me. And so I can do what you want. And so I'm going to give you an advertise. And so we're gonna break that up. It's a little bit of a big packet. So we'll look at it in the next two foils. Remember, so then here's your transaction ID again, 41F8. And then we say, okie dokie. So then, okay, so this is our link local address. And then we're going to create this identity association, which is going to be your global unicast. And this is just from something I made up. You know, I mean, there's no 2000 V6 destination. As I say, I just made all this up. So, and then how long is it going to be valid? Okay, so let's look again. And so the identity association says, yep, I got you. I gave it to you, and this is the address, and these are the DNS servers that I'm going to grant. And now, how does this guy know? How does he know what the DNS servers are? Again, that's going to be in your configuration. Is you're going to need to do that? Is put that in. So then, what's the next packet? Well, that's the request. That's the third message in the sequence. What we're looking at here, again, coming from source port 546, going to 547, and he says, okie dokie, what am I doing here? I said, I want a confirmed assignment and other stuff. And so what are we talking again? We're talking, I broke this packet up too much. It's going from the link local to the multicast, link local to the multicast. And here I've got this V6 address that the advertise gave me. He said, I just want to make sure that this is what you want me to use for all this. And here's the server identifier in here. So then here's the reply. This is the last one. And he says, yep, this is exactly what I want you to do. And I'm confirming that this is all the DNS servers that I want you to use. And so let me, this is the what do you call it? This is the scheduled part of the presentation. Let me take some questions now. Hang on a second, and do feel free to go ahead and put them into the chat box if you haven't seen it. I mean, if you haven't, I mean, not the chat box, the question thing. Oh, and you know what? Let me, hang on one second. Let me unmute Michael so that Michael can answer questions as well. 1 minute, let me find him. And I hope he hasn't said like, okay, I'm not doing this. Okay, here we go. Okay, all right. Michael, I've unmuted you. Can you hear okay now?
I was trying to think of some, you know, when you unmuted me, I wanted to be halfway through a sentence about, you know, oh my God, the dinosaur's about to eat me or something. But I didn't come up with something like that. So there you go.
All right. Well, thank you so much, Michael.
I'll just comment about the point about Android and DHCP. It's a real disaster, and it's based upon one or two engineers which are well known at the IETF who don't seem to believe that Android is used in devices other than phones. I, for one, for instance, wish I could DHCP my Android TV because I would like it to have a specific address that I give it. And I don't know how that's going to get resolved, but somehow it's got to get resolved, particularly as it gets moved into more and more places that are not phones. And the other issue is, of course, if you don't have DHCPv6, then you can't do prefix delegation. You think, why would I need that in an Android device? And the answer is because you want to tether. And I think that's the biggest missing part about there is you want a DHCPv6 server and client in Android so that you can tether through your LTE to your desktop with v6 for the cases when the internet dies.
Let me, yeah, you know what? Yeah, let me, for those people who didn't catch the beginning of this, there's questions that we're getting about what is the status of DHCPv6 on Android, and the question was that they said that people wanted to use it, and the bug, it was reported as a bug, and the answer was not a bug, feature. We're not doing this. And like Michael said, I mean, we know exactly who it is who's saying we're not doing this. Anyway, so there's nothing to say. I suppose if enough people bring pressure to bear, it's possible to change. I don't know. What is your thought, Michael? Or if anybody else has thoughts?
Well, I mean, if I were sending in an RFP for 1,000 digital signage devices, I would love to run Android on it. I think that's a great choice. I think it's perfect for any number of reasons. But I really would like to have DHCP on that, and I would put that in the RFP. And then I would wind up probably with the proposals with Windows XP. Obsolete Windows XP is what I would receive because they couldn't do Android, and that's unfortunate. So I mean, that's a good example. I think that's a situation where you would really prefer to have DHCP back and forth because you really do want to have the devices clearly identified.
Now, guys, on this particular session, I know there's quite a few of you who are from very large organizations and also government. And so just keep that in mind, is like, you do have, as Michael said, you have power with purchasing. And so yeah, it's a really good point. So let me take one of the other things. And now, so this is this question, it keeps coming up again. And of course, I have my opinions, and I'm sure, Michael, you have yours, and others on the call will have theirs too. So let me read the question, and then we can discuss. Okay, so USGv6 and IPv6 ready include DHCPv6 Guard, RA Guard, and MD snooping requirement and he cites a NIST document. And for anybody who's interested, I can certainly send you that NIST document. Do send me a quick note on that. So Michael, I'm gonna let you go first. What is your opinion on this?
On the need for the Guard?
Need for the Guard, effectiveness of the Guard, and whether everything is covered, just that whole area, and maybe even like if you have experience in having seen avoidance and evasion by it.
Well, so DHCP Guard was necessary in v4. Otherwise, everyone who clicks poorly on their Windows platform winds up sharing their wireless and they're wired and renumbers the network by mistake. So this has been necessary for more than a decade on most networks. So DHCPv6 Guard is actually a lot easier to implement by the switches, but it's probably implemented pretty much the same place anyway. It's important. It's important because that with it present, then your server, your machines can depend that the DHCP replies they get are in fact from the legitimate server as opposed to an attacker on your network. And there's a fair number of things, for instance, in the DPRIV and ADD working groups of the IETF, where we're discussing the question of, well, how do I upgrade from insecure DNS to DNS with privacy? And the answer is, well, if we can't assume that DHCP Guard works, then we can't assume anything. So that's pretty important. And I wish it was enabled on more devices below the enterprise level. I wish it was enabled on the SOHO type devices. OpenWRT has some capabilities in it, so it's in some home routers. But there's lots and lots of devices that you commonly see in small enterprises that do not have it and really could benefit from it.
Yeah, well, and you know what? One of the things, you guys, let me send you another note because what I want to do, I mean, you know what? It's like I have the hacker mentality, and I feel like, okay, you gonna put this up? Let me see if I can break it. And so we might just try that if that seems like a fun thing to you. I mean, to everybody on the call, is it's going to be a 2022 activity. I'm just going to tell you because we're like super busy. But could not agree more. Is like people going to exploit what's not there. And you know, if there's things we find in the NIST document, NIST is just, I mean, they're just wonderful people. And we can send them and say, look, people, you know, privately, of course, say we found this, or CERT, and say, you guys, we tested it, we found this, we found that. You guys might want to, well, fix and or alert. Because, you know, I tell you something, one of the things that makes me very, very nervous is not feeling completely certain that a bunch of holes are plugged before saying, people, let everybody use IPv6. You know, I just want to feel really, really sure that in our environment, in the real world, that we're not going to be able to create damage with holes that are there, with scale, stuff like that. And so to me, I feel like this is the purpose of what we're doing here is let's talk about it here and talk about things like, you know, already I'm getting questions like, you know, like people saying, yeah, your DR example is super interesting. We're going to need that. Or, you know, multi-homing, that kind of stuff. So how does it really work when you've got multi-homing going on, multiple networks? And to me, I think it's one thing to talk about it, but the real thing is let's be going ahead and setting up these scenarios. See if we can emulate a typical complex enterprise scenario and say, okie dokie, you know, we just had to do disaster recovery. We had to do hot backup, something like that. And I will say that is a conversation that some of us are having in the background about what we might want to see in that kind of scenario. And if you have ideas for what you'd like to see, or if you think that would be super valuable to you, because what I'm thinking is instead of everybody trying to do all that themselves, maybe we consolidate and try and get it. And not that I want to replace any of the wonderful labs and everything that's out there. I just think they don't have the perspective of the folks that are on this call, which is large, complex enterprises. Mike, what is your thought on all this?
All right, I don't think I quite understood what you're talking about.
Well, okay, because I was probably talking about a whole bunch of stuff. Well, what I think, I guess to cut to the chase here, is I think we need a sandbox environment that kind of emulates a typical enterprise or even a complex enterprise with the kind of, which does the kind of the operational, which has the operational challenges that enterprises have, which is things like hot backup, disaster recovery, and that kind of stuff. And then see how do we handle it with IPv6? Is that kind of more? Does that make more sense?
Sounds interesting. I don't know how one can build such a thing, and it's so different between enterprise to enterprise and all of the different kind of things. So I think it's an interesting challenge, but I don't know that it's that. I don't know how. I don't know how. We have a problem of that. We can't just turn everything off and try it all over again, right? For most enterprises, and I think that's actually more their problem, which is that they don't know how to incrementally deploy things, rather than that they need to somehow simulate everything, all problems before they can do anything. And I think that's a kind of analysis paralysis problem. And my opinion, you should just do it, right?
That's really interesting. That's a very good point. Guys, if there's anybody else who wants to talk, do hold up your hand. Let me see if I can see the attendees, and then do feel free to and I can just unmute you. Go ahead and raise your hand, and I'll unmute you. Let me get this. I'm having trouble manipulating all these things. That's a really important point, Michael, is the point of maybe a strategy for incremental, the idea of incremental implementation. But the reason about trying to find as many flaws as you can is the reality of enterprises is that if people don't want to do this anyway. By people, I mean a lot of management. Maybe a lot of technicians too. A lot of people don't want to do this anyway. And then the second that there's a problem found, people are like, see, I told you, shouldn't have done it anyway. Pull it back. You see what I mean? And that's why, like, I get nervous, and so that's why I want to try. But what you say is a really important and interesting thing. Is maybe, like say, okay, well, let's just do this, and then see if it works, and then scale it. Like do, like if you're in Michigan, do Kalamazoo, something like that, or do one VLAN, or do, if you're a university, let's do the hostel where the freshmen are. I don't know. I'm just making all this up, And then if that works and it runs for, a month, then we move to something else. Is that the kind of incremental implementation? That's kind of what you're thinking?
You can do, that's one way to slice it, is by network. Another way to slice it is by service.
Oh, right.
Okay, so your public facing web servers, your database network, there's a lot of different ways of doing this, and recognize that also that Facebook, Google, LinkedIn, they're all running IPv6 only in the data center, and they have IPv4 bolted on the front, and that's not new. That's some cases a decade old now. So there's a lot of different ways of doing this, and I think the most important thing, the first network that enterprises should do, is they should do the network that the IT people, support people live on, because until they've experienced it, there's no way they can fix anyone else's network.
That is a really good point. That's a really good point. Do your campus network, wherever the systems programmers or whoever are. Well, great. Thank you guys all so much. Any other questions? Please send me an email. Any other closing thoughts, Michael? And thank you so much for getting on. No? All righty. Well, thank you guys so much. And I will be sending out the recording as well as the PowerPoint, and hope to see you at the lab next week. Thank you. Bye.